So let's jump into removing from a linked list. Bring this over here. So removing from a linked list is a little more complicated. So when we want to remove from a linked list, we have to, it takes in what we want to, the data that we actually want to remove. So if that data exists at the head node, so if like the current node, if the head node dot data equals what we're trying to remove, we just want to reassign the head node to the next node. So we're essentially assigning it to this node. So if the head node dot data, the data within the head node equals what we're trying to search for, we're essentially going to reassign the head node to equal the next node. So now what was originally the second node in the list, in the linked list, is now becomes the head node. So I'm going to come down here. So I'm just going to start remove, takes in some kind of data that we want to remove, that we actually want to search through the linked list to remove. I'm going to just do current node equals self.head. I always just want to reassign the head because this may change in the future. So if I can say, like, if the current node dot data equals data, then I want to reassign the head node self, so self dot head equals, what do I want the head node to be assigned to? The current node's next node. So current node dot next node. And we can kind of show you that down here. So I'm adding, 4, 7. I'm adding this massive linked list. If I want to, I'm going to print current node dot head. I'm sorry, current node dot data, and then print self dot head dot data. So for this example, I'm going to try to remove the very first 4. I'm going to remove the element 4. So I created an empty linked list. I added 4, 7, 2, 8, 6, 9, and 1. Now I want to remove, remove the number 4. So the 4 is, I'm going to comment that out. I just want to double check to make sure 4 is in fact the head node. Yep. So coming down here, it's printing the head node, which is, so it has 4. If I wanted to remove 4, it's going to come up to here, take in 4. The current node, I'm just going to assign it to the self.head because I always have to start at the very beginning of the linked list. That's why I'm starting with self.head. And I'll print the current node just to double check, make sure that that is in fact the head node, or should be 4. So if current node.data, which should be 4, equals 4, it's going to jump into this block of code. So then I'm going to reassign self.head to the current node's next node, which should be 7. And then I'm going to print self.head.data because I've reassigned the head node. So up here, this should equal 4, and down here it should equal 7. If I run that, Python linked list, what happened? Current node dot next node. Why didn't that work?
You don't have an assignment operator there.
Oh, thank you. self.data. So yeah, I had the double equals, which, so let's try that again. So there we go. I'm printing 4 here, which is on line 38. I'm invoking remove. I'm passing in 4. Comes up here, assigning a variable current node to self.head. I'm printing the current node's data, which is 4, which is the head. Current node dot data equals 4. If the current node's dot data equals the data that I'm passing in, which it currently does because 4 equals 4, then I'm reassigning self.head to equal the current node's next node. So then I'm just printing the self.head, which is the reassigning the head node. I'm printing the data at that point, which is 7. What questions do you have about that? Because then now comes for a little tricky part of removing a node in the middle of the linked list. So if I want to remove, for example, say this is like 4, 7, I don't remember what the other one was. 2. Present. So 4, 7, 2. If I wanted to remove this node, what I'm going to have to do is, again, start at the head node, check, say, hey, does the head node, which I'm assigning it to a variable called current node, does this data equal whatever I'm trying to remove? If it doesn't, reassign the current node to equal this next node, which is then here. And then if this current node's data equals what I'm trying to remove, or if it doesn't, then again, reassign the current node to the next node, so which comes over here. And so that's the node I want. So if the current node's data equals what I'm trying to remove, which it does right here, I need to remove it. But now I need to somehow reassign this current node's next node to equal essentially this current node that I'm removing. I need to assign it this node's next node. So I need to assign it to this. So this current node, next node, needs to be assigned to this node's next node. So once I get to here, I'm gonna have it assigned to my current node because that's the current node I'm on, and then I have to keep track of the previous node as well. So at some point, I think I'm gonna have to have a variable called previous node to keep track of the previous node. So once I find the node that I want, which is node.data equals 2, I need to assign this previous node's next node to equal this current node's next node. And then at that point, which is essentially this next node equals this, and then then everything will be in line with one another with this node being removed. So with that, so in addition to having a current node, I need to keep track of a previous node, which initially is none, because when we first start at the very first node, which is the head node, there is no previous node. So I can get it here. And else, while the current node dot data does not equal data, I need to assign, essentially my current node is the head node, but now I need to assign the current node to be the next node, but then I also have to assign the previous node to, the current node, the old current node. So the first thing I need to do before I move, I need to assign the previous node to the current node, and then I need to assign the current node to the current node's next node. It's kind of confusing. So I need to assign the previous node to equal the current node, and then I need to reassign the current node to equal the current node, which is this head node right now, dot next node. And then once I actually find it, like when the current node's dot data equals what I'm actually trying to remove, I can assign the previous node's next node to equal the current node's dot next node. So what this is actually doing is completely removing the current node from the linked list. And then I think at the end you can just return, self dot head. I think that's the specific standard of what you should return when you remove it. So let's see what happens. So if I wanted to remove 2 from this, I can do, let's actually first print new node, new linked list dot head dot next next node dot next node. Let's do dot data next node dot data next node dot data. I just want to see, I want it to print the 3 items that we're going to try to remove. Whoop. What's that? So 7, 2, 8. So I guess we can print. Oh. 4, 7, 2, 8. Now, if I wanted to remove the 2, I can do new linked list dot remove 2. So it's going to come up here, dot data. Always have to start at the head node. So current node is the head. We don't have a previous node to start out with. If the current node dot data equals data, then we're just reassigning the head node. But we do else, so we're going to jump it down in this else statement. If the current node dot data does not equal data, so if the current node, which is 4, does not equal 2, jump into here, previous node equals the current node. So now the previous node equals the head node essentially, and the current node equals the head's next node, which is 7. And it's going to come back up here in this while loop. If the current node, which is now 7, does not equal data or does not equal 2, the previous node equals the current node, which is previous node was the head node. Now it's equal to the node where 7 exists. So the previous node equals 7. And now the current node equals the 7's next node, which is 2. So now my current node is 2. Current node dot data equals 2, or it's going to jump up here. If the current node dot data 2 does not equal 2, but it does, so it's going to jump down here, and it's going to assign the previous node, which is 7. Next node equals the current node, which is 2. It's going to the current node, which is 2's next node, which is, what is it? 8. So if I remove it, it's just, all right. But now if I print everything again after I removed it, just show you after. This is what it's going to be like afterwards. If I print it. So initially, before I removed everything, it's 4, 7, 2, 8. Now it's just 4, 7, 8, and then 6, 9, whatever. So that's how you remove from a linked list. It's a lot of reassigning variables and just traversing the linked list one at a time, keeping track of the previous node.